Going on, guys, we have this question right here. It's asking, determine if the following vectors are linearly independent, and they have given 1 2 3 5. So first of all, in these kind of questions we have to create a system. So let's say we multiply the first one by c1, so it's going to be 1 comma 2, and plus, let's say we multiply the second one by c2, right? So it's going to be 3 comma 5 and equalize to 0. So if I equalize to 0 and find the equation for this one, it's going to be c1 plus 3c2. How did I do that? I just multiply the first one here and first one here and equalize to 0. The second one is going to be same thing. It's going to be 2c1 and it's going to be plus 5c2 equal to 0. So this is my two system of equations. Then what I can do is I have to simply bring it into this method to solve in Gauss-Jordan method. So to do that, I have to bring it in this form. It's going to be 2 1 3 matrix form, right? So 1 3 2 5. This is 0 0. So if I do the Gauss-Jordan for this one, it's going to become like 1 0 0 1 0 0. So since this one is true, we can find that c1 is equal to 0, c2 is equal to 0. Therefore, if you see the leading coefficient, so these are the two vectors. 1 2 is one vector and 3 5 is a vector. So we have two vectors right here and we have two leading coefficient. So if we have two vectors and same amount of leading coefficient, it means this these vectors are linearly independent. So that's the way to prove this one is linearly independent. And in case if you have one leading coefficient and if you have two vectors, that means this is linearly dependent. That's another way to, if you have question like find whether it is linearly dependent. If you have different amount of leading coefficient and different amount of vectors, that means that's linearly dependent. So this is how we do this question. I hope you guys understand this. See you next time.